Hey guys, today we're going to look at a different format that we can manipulate our quadratic equations into to help us plot them. So we've previously looked at turning point format and how we can complete the square to get a quadratic into turning point format. Today we're going to look at what's called root format or x-intercept format. And we've actually seen this a lot in the past. So you'll see what I mean in a second. So if I have a quadratic equation y is equal to x squared take 2x, the first thing I might note is that when x is equal to 0, y is going to be equal to 0. So my y-intercept is going to be, of course, when x is 0, and we see when x is 0, cancel, cancel, we'll have y is equal to 0. So our y-intercept occurs at the origin. And now what I'm going to do to kind of get a better idea of what this quadratic equation looks like, I'm going to factorize it. Oops, I didn't even factorize it. I'm going to factor out this x. That's going to leave me with x take 2. And just like how when we have the y-intercept, x is 0, well, when we have the x-intercepts or the roots, y is equal to 0. So once I factorize this, I'm going to set y equal to 0. And that's going to give me some solutions for x. So x, when y is 0, remember the null factor law, we're either going to have x is 0 here, or x take 2 is 0, because this times this equals 0. That means one of the two, or both possibly, has to be 0. So our solutions, we have either x is equal to 0, or x take 2 is equal to 0. So our solutions for x, of course, x is 0, or x is positive 2. Okay, how does that help us? Well, we've just found the y-intercept from the very start, just by looking at this general format. And then when we factorized into root format, we set y equals 0, and we can immediately read both of our roots. So if I were to sketch this out now, I know that one x-intercept occurs at 0, so this is going to be the point 0, 0, and 1 occurs at 2, 0. So that's probably somewhere right here. So 0, 0, 2, 0. And we also see that the y-intercept is at the origin here. So a quadratic is going to look something like this. That's a bit cool. Let me do that one more time. You guys get the idea. So we can see that factorizing, getting this into root format, setting y equals 0, and solving for our x-intercepts or our roots helps us to immediately plot out this parabola because we know where it's supposed to intersect the x-axis. And we can also find out very easily when it's going to intercept the y-axis just by looking at the general format. You know, if there's a constant, one step's going to be equal to that constant. But anyways, this isn't the complete picture. So just like when we had turning point format, we needed to find the roots manually. Well, now we need to actually find this turning point manually. It's actually not too bad though. So remember, this parabola is exactly symmetrical. So that means I can find the x position of this turning point because it's exactly symmetrical, right? That means this distance from my turning point to my root to the right is going to be equal to the distance of from my turning point to the root on the left because this quadratic is symmetrical, right? Well, I can see that there's a total gap of 2. That means if I cut it in half, that's going to be a distance of 1, that's going to be a distance of 1. This turning point here must have an x value of 1, right? So we know that this is 1, something. So to find out what the y value is here, we'll just take x is equal to 1 and substitute it into our original equation up the top. So y is equal to x squared take 2x, and we're going to look when x is 1 because we know that's the value of x at the turning point. So we're going to have 1 squared take 2 times 1, that's going to be 1 take 2, negative 1. So we see that the y value down here is negative 1. So our turning point, 1, negative 1. So pretty useful for getting these roots out, but we have to find our turning point manually. All right, let's look at one more example. So the first thing we might notice, when x is 0, y is going to be equal to 5. So our y-intercept is going to be 0, 5. Okay, now let's try get this into root format by factorizing. So y is going to be equal to, well, let's open up two brackets here. And we're looking for two numbers that add to give negative 6, but multiply to give positive 5. Well, that's going to be negative 5 and negative 1. Negative 5 plus negative 1 is negative 6. Negative 5 times negative 1 is positive 5. So we got this in root format now. The reason we want it in root format is because I can easily say, well, when y is 0, that is going to give me the value of my x-intercepts. Well, when y is 0, using the null factor law, either x take 5 is equal to 0, or x take 1 is equal to 0. Right? So x take 5 equals 0, or x take 1 equals 0. That means x is equal to 5, or x is equal to 1. So we found our roots. When y is 0, x is 5, or it's 1. So our roots, or our x-intercepts, are going to be at 5 and 0, and 1 and 0. So if I sketch out a quick axes, maybe 5 and 0 somewhere over here, maybe 1 and 0 somewhere over here. We saw a y-intercept was at 0, 5, so maybe this is 5. I'm going to have something like this. And we need to find this turning point so we can label it. Well, I know that this turning point is going to be exactly in the middle of my two roots. So the value of my roots are 1 and 5. How do I find the middle point between 1 and 5? Well, that's just going to be the average of 1 and 5. This turning point is going to be at a value where x is equal to 3. Why? Because that's the average of 5 and 1. So x at this turning point is equal to 3. Now to find the y value, I'm just going to go back to my original equation. Oops. Y is equal to x squared take 6x plus 5. And I'm going to substitute in a value of 3 for x. And that's going to give me the y value at my turning point, right? So y is equal to 3 squared take 6 times 3 plus 5. So 9 take 18 plus 5. 9 take 18, that's negative 9 plus 5, 9, 8, 7, 6, 5, 4. That's going to be negative 4. Y is equal to negative 4. And just looking at this, that seems about right. Seems about right. Somewhere down in the negatives. So we can plot our turning point right there. And here we have a sketch of our parabola. Let's look at one more quick example. Sketch the quadratic of the equation y is equal to x squared plus 6x plus 9. So very similar. We'll see that the first thing, y-int, is going to be at 0, 9, right? When x is 0. If I get this into root format, well, two numbers that add to give 6 and times to give 9, that's got to be plus 3 and plus 3. 3 plus 3 is 6. 3 times 3 is 9. So y is actually going to be x plus 3 squared. This is basically turning point format. We can see, by looking at this through the lens of turning point format, that we've just taken our quadratic and we've shifted it 3 spaces in the negative direction. So we're going to have something that looks like this. So we know that from turning point format. But Uh, if we do what we've been doing, we'll say, all right, so roots are x plus 3 squared, so 0 is equal to x plus 3 squared. That means x has to be, excuse me, that means x plus 3 has to be 0. X plus 3 squared is equal to 0, that means x plus 3 must be 0. Okay, well, x then has a value of negative 3. And because it's the same root, right, it's actually only one solution for x. X is equal to minus 3. And so what that means, it means that if we have a parabola and its root is at minus 3 for x, and there is only one root, we're only going to be touching this x-axis. And we saw that we intersected the y-axis at 9, so maybe 9 is somewhere up here. A parabola will look something like this. Okay, cool. Hopefully that's enough. Checking out.